Hello everybody, my name is Minko Gechev. I'm an engineer in the Angular. Today I would want to share with you what is the current state of the Angular deployment, server-side rendering, and pre-rendering. I'm going to put a couple of updates about what we built over the past couple of months into the context of the evolution of the web. And I'm going to mix everything together with my personal story, how I got introduced to web development. So I'm pretty excited on sharing this content with you. Well, first, let us go to 1991. When the first website ever was deployed to the internet. It looked something like that. We had this fascinating infrastructure of distributed network of web servers that were serving static HTML files that were linked together through hyperlinks. We were just serving these static files, but if one of these web servers went down, everything was still working properly because we had this fault tolerance. At the same time, serving just static files wasn't satisfying the requirements of the business. So that's how different developers came up with the idea for the common gateway interface. CGI is just a way for the web server to pass the user's request to an external program that can fetch some data from a database or read a file, and right after that, return some rendered content to the web server that the web server was able to forward to the browser. This way, we were able to build much more dynamic experiences. We were able to generate automatically the page and store some data provided by the user. So here is how this looked like in terms of boxes talking together. First, the user is requesting an HTML page from the web server. The web server is forwarding this request to an external program, which was fetching some data from somewhere. And right after that, generating the content that the user was supposed to see in terms of markup. This markup was rendered by the browser, and at this point, we have the largest contentful the page. So at this point, the page is already useful. The user can engage with it, can read this content, and can do their job. So the largest contentful paint is a user-centric metric for estimating when the page is useful for the user. This is an important metric that we're going to mention further in this talk. Although this was decent, and it served the business for a bit, still we were far from desktop-like user experience. We didn't have this responsive experience that people were used to from their desktop applications, where just by clicking on a button, something was happening on the screen. On each tiny interaction with the CGI architecture, we had to reload the entire page instead of just updating a subsection of it. With the evolution of the web and different web technologies, such as the iframe, and XML HTTP request, we came up with the technology AJAX. AJAX is an umbrella technology which includes different APIs that we can use in order to send asynchronous requests to a web server, fetch some data, and right after that update just a tiny portion of the screen. Here is how things looked like back then. We're still sending requests to the web server, which was forwarding this request to an external program through the common gateway interface, which was fetching data from a database, let's say, and right after that returning rendered contents to the browser. And the browser was able to render something, so it was making the page useful at this point with the largest contentful paint. Right after that, the page was also referencing some JavaScript files. And these JavaScript files were making the page interactive in terms of desktop-like user experience, where they were adding different event listeners to certain DOM elements. And just by clicking on any of these elements or somehow interacting with it, they were able to trigger asynchronous requests, fetch some data from the network, and update only a small portion of the screen instead of reloading everything. So that was the time when I got introduced to web development, thanks to my high school teacher back then. This is the authentic cover of the first book that I read. This is Bulgarian for development of web projects with PHP and MySQL. Yes, I started with these two technologies. I was not really sure what I'm doing, and this was a pretty heavy read, over 500 pages. So I just read about some APIs, and I pretty much learned them by heart because I really didn't know what's happening under the hood. So that MySQL has some drivers for PHP, and they were sending some requests over the network and fetching data through TCP sockets. I had no clue. But I built this website, which is in fact a CMS system. That is one of my first websites. And it had a lot of AJAX, a lot of messy code. But I ended up presenting it in front of an audience consisting of these two people in 2008. So this audience was a bunch of web experts in Bulgaria. They evaluated my websites, and thanks to this, I was able to go to university. I built a website back then based on this CMS system for meteor showers, for observation of meteor showers, because I was pretty excited, pretty passionate about astronomy. Around the same time, 2008, 2009, things got pretty intense in terms of development on the front end. We had Backbone and Angular JS, which put some structure on the web applications that we were developing, that we were building. These two technologies helped us to build more rich user experiences with JavaScript. And they dramatically changed the way that we are rendering pages. From the server, we directly went to the client without rendering absolutely anything from the server. So we were using the original architecture from 1991, where we were just serving static HTML files, and right after that, loading a bunch of JavaScript files that were executed and fetching some data from the network, and finally rendering something useful onto the screen and making the page interactive. The page is really interactive with single-page apps, as we all know. We really provide desktop-like user experience, but at the cost of making the user wait for a long time until we show something useful onto the screen. And that is very far from ideal, right? We spent a lot of time in just loading scripts, and the users, we don't provide any useful information to the users, so they very often just leave the page since there is nothing there for them. As framework authors, we're spending a lot of time on optimizing the user experience and optimizing the bundle size in particular for your applications and for the framework itself. During the first day of the conference, from Kara, you heard how we spent, how much we invested in making sure that Angular is tree shakeable. We're generating the optimal set of instructions for your templates so that we can make your bundles smaller. At certain points, we even had the joke around version 4, like that's the same joke as the previous talk, in case you didn't hear it the first time. We had this joke that by version 5.4, we're going to make Angular's bundle size negative. So just by adding the framework to your application, we're going to shrink your bundle size. Like, that's obviously not possible. And we still have a lot of work to do in order to optimize the Angular and to make your bundles even smaller. But at a certain point, you just need to ship some JavaScript, right? Like, you should definitely invest in making your application smaller. But at a certain point, your bundles just can't get any smaller. I put this very insightful quote here for myself. And that was, in fact, one of the motivations for different folks trying to run this client-side rendering on the server in order to have some code reuse between the client and the server and return some rendered contents to the user ahead of time. That was around Node.js was getting traction. This was probably 2013, 2014, maybe a little bit before that. Different folks from the JavaScript open source community tried to experiment with server-side rendering of client-side applications just by mocking some browser APIs. And we went back to a similar architecture to what we previously had with CGI. We have a client browser, which is sending a request to a server. And this time, instead of forwarding the execution to an external program with CGI, we were just running a client-side application in Node.js environment. At this point, this client-side application is not using the DOM APIs in the way that they're used in the browser, but it is using Node.js implementation of them, and it was actually returning a rendered content that the user was already able to use. So they were getting the largest contentful paint on time. And later on, the browser was downloading a bunch of JavaScripts that were making the page interactive as well. 2014, around this time actually, I gave my very first international talk on ng-Vegas. I was super nervous. In fact, after I gave this talk about my research on Angular JS and how we can use immutable structure with it to speed up our applications, like after my talk, I just went to my room and I locked myself there and I stayed until the end of the day because that's how nervous I was. Like, it was a pretty huge experience traveling 6,000 miles from Bulgaria to Las Vegas to share my work. And on this conference, I met a lot of fantastic folks. One of them was Patrick. And Patrick, together with Gechev, 2 months later, they presented their initial prototype for Angular's first server-side rendering, Angular Universal. This is a really exciting project that is still being developed very actively between the Angular team and the community. And since then, this project evolved a lot. It is now a robust industrial solution that a lot of really fantastic companies are using in production. I want to invite Amanda on our virtual stage from Crunchbase, who's going to share more on how Crunchbase is using Angular Universal.
Hi, ng-conf. I'm Amanda Cifaldi. I've been an engineer at Crunchbase for 4 years. And I'm here to share why Angular Universal is just so important to our team. Crunchbase is the leading destination of private company data on the internet. It started almost 15 years ago as a small database for tech reporters to keep track of funding data. 4 years ago, we became our own private company with a mission. And that mission is to democratize access to company information and provide solutions that guide our users to their next opportunities. But at the time we spun out as a private company, we had a Rails application, and some of the pages were taking nearly 20 seconds to load. And adding more data would make those pages even slower. So how are we going to deliver on our huge mission as a web platform? We knew we had to start from scratch with a foundation that was going to allow us to deliver new data to our users quickly without having them pay for that in their load time. Enter Angular Universal. Server-side rendering our pages means that we can surface data faster to places where web users are searching for and sharing that data. And really importantly, we're doing that all in a singular code path. It also means that when users go to access that data on our platform, we're getting it to their browser in the quickest and lightest way possible. When we think about how we make our data discoverable and accessible on the web, we're talking about web crawlers. The Google crawler has a two-wave approach to indexing sites. The first wave of indexing takes into account any HTML that it can access by requesting the source code, as well as adding in any links that are in the source to the crawl queue. The second wave of indexing renders and indexes JavaScript generated content. And this can be hours or weeks behind that initial wave of indexing. So if we were in that second wave of indexing, access to newly added information on our platform would be limited to the users who already regularly visit us. But what if you were searching for a new job and you didn't hear about the latest funding rounds a company got because our pages were a week behind getting crawled? Making decisions about opportunities is all about timing, and we want to be in that first wave of indexing. Because over 70% of the traffic that we get to crunchbase.com is attributed to organic search. So in addition to showing up in search results as quickly as possible, rendering our pages on the server also means that we're able to add semantic information to our pages, which enables us to better represent our data. Having the ability to add structured data to our pages helps to classify the full contents of our pages and enables us to show in special search features like cards. And Open Graph tags allow us to show up with descriptions, titles, and images when pasting them in various contexts. This means that as much as possible, our data is accessible to our users wherever they are, even if that's not crunchbase.com. And what does it mean for the users who do visit crunchbase.com? We serve over 2,000 pages per minute to 1 million users a week, to users on 6 continents, to the tune of 150 milliseconds per request. Responding with fully formed HTML from the server means that we're getting information to our users as fast as we possibly can. And as a small team of engineers, we value Angular Universal as a tool that allows us to deliver on our huge mission. We've been with Universal since the 1.0 beta, and we look forward to continuing to learn and improve along with the community.
Thank you very much, Amanda. Talking to a lot of developers on conferences and like any external events and external forums, we often hear about two main challenges: change refresh time and deployment. So we heard this feedback and we did a couple of improvements in version 9. In version 9, once you add the Angular Universal schematics to your project and you make your project an Angular Universal compatible, you now have an Angular CLI builder serve SSR, which allows you to have the same live reload experience as ng-serve, but this time for Angular Universal application. So this is not a complete replacement of ng-serve, because we need to build more things. We need to build both the server and the client, and it is slightly slower. But at the same time, it is really great to not have to rebuild your client, your server, and right after that, start your development Angular Universal server every time when you make a change. This way, just by running ng-run, the name of your app, serve SSR, you will be able to have live reload and you'll be able to test each piece of code and each change that you do to make sure that it works both on the client and on the server. In order to take advantage of this feature, everything you need to do is just run ng-update ng-universal/express engine. And this is another example of this fantastic collaboration between the open source community, the Angular team, and like different people with different backgrounds. Here, Alan from the Angular CLI team worked in collaboration with Manfred, who is one of our fantastic committed collaborators, to build this experience and make it available for everyone. Another example for the collaboration that we had was in terms of deployment. So there are many different ways to deploy an Angular Universal application. There are fantastic tutorials online, but at the same time, there are a lot of boilerplates that we can definitely eliminate with schematics and all the power of the Angular CLI. So in collaboration with the Firebase team at Google, we worked on introducing deployment schematics for Angular Universal applications as part of Angular/Fire. Let me show you how this works. So here, I am in an Angular CLI Universal project with the Express engine. All I need to do in order to deploy this application to production with Firebase functions is just run ng at Angular/Fire. Here I'm adding a Canary version because I recorded this video while this functionality was still experimental. Now I'm waiting a couple of seconds to install a couple of dependencies, and right after that, Angular Universal Angular Fire schematics detected that I'm inside of an Angular Universal project and suggested me to deploy it as a Firebase function. Everything I need to do at this point is just agree with the Firebase schematics. And once I do that, Firebase is going to install a couple of other dependencies, which would help us in our deployment. It's going to prompt us to select one of our Firebase projects. And now we can just run ng-deploy. Once we run ng-deploy, this is going to build our application, both the client and the server. And right after that, start deployment process. It is going to deploy our static assets to Firebase hosting. So it is going to use a CDN and provide the static assets from the closest location to the user and deploy the server to a Firebase function. Once we click on the URL, we can see that we already have our application deployed to Firebase hosting and it is all server-side rendered. So we were able to achieve this with just two commands, ng at Angular/Fire, and right after that, ng-deploy. When talking about deployment of universal applications, we often have a couple of things to consider. For example, we already mentioned that we are running the application on the server, right? But very often, a lot of these applications that we are rendering, they do not change at all. They're pretty much static applications. They're pretty much static pages that don't depend on any dynamic parameters at all. What we can do in this case is introduce a caching layer. This caching layer can help us to speed up the server-side rendering and not perform it when possible. So first, the user request is going to go to this caching layer. If we find that the response associated with this request is already there, we can directly return it to the user. And this is going to be pretty fast. On the other side, if it is not there, we can perform server-side rendering, cache the response, and right after that, return it to the user. Once the user has the response from our server-side render page, we can just download all the associated JavaScript and bootstrap the page, just hydrate it. And this works all right. This is great, in fact. But at the same time, we have this redundant caching layer. And we are rendering a lot of pages that don't really have to be rendered at request time, right? Because they do not change at all. So we shouldn't make the user wait until this page is rendered on the server at all. Like, we should render it ahead of time. And that is where we can use prerendering. Prerendering is a technique which is very similar to server-side rendering, but instead of rendering the page at request time on the server, we're pre-rendering the pages as part of our build process. This can speed up a lot of things. It is going to make our deployment maybe a little bit slower because we have to upload more assets and we have to have longer build time. But at the same time, it is going to reduce the time required for the user to extract to get the initial page load, because we can directly provide it from a CDN instead of rendering it on the server. As part of Angular version 9, as Wagner already mentioned during the first day of the conference, we already introduced a pre-rendering builder for the Angular CLI. You can build your project with this pre-rendering builder just by running ng-run, the name of your project, :prerender. Once you trigger this command, we're first going to build your application. We're going to produce all the production assets for both the Angular Universal server and for your Angular client. And right after that, we're going to start a pre-rendering process, which we played a lot to optimize it, quite a lot. In this case, you can see that we're pre-rendering 400 pages for less than a second. And this is only possible because we are pre-rendering the individual pages on different cores of your machine in parallel. Some folks from community, they did even more aggressive experiments. Here, Steve pre-rendered 10,000 pages in 75 seconds, and this also includes the build time. The build time is taking, I would say, probably about a minute out of these 75 seconds, which is pretty impressive. All these features that I'm talking about, they're making us even better solution for the Jamstack. If you haven't heard about the Jamstack, this is this initiative for building client-side applications just by using JavaScript, APIs, and markup, just by deploying them to a CDN. This way we can build very fast applications, and we don't have to think about deployment at all, because these are just static assets. We can put them on CDN and forget about it. With Angular Universal, you can already do that pretty easily. You can just run ng-add, ng-universal/express engine, and right after that, pre-render your app and deploy it with either ng-deploy or with GitHub. There is also a fantastic community project by Hero Devs, Scully. This project is a full-fledged static site generator with a lot of plugins that allow you to get different information from different data sources. It uses different pre-rendering mechanism compared to Angular Universal. Instead of using Universal, it uses a headless browser, which visits the pages in your application one by one, which has its own trade-offs. It is a very complete solution, so it can pre-render pretty much any page that works in the browser. On the other side, it is a little bit slower compared to Angular Universal, which is really fast, but at the same time, it may not work for all of your pages, especially if you're touching some browser APIs that are not available in Node context. So I don't know if you felt my excitement here and how many times I said collaboration between different parties, but that's one of the main reasons I'm pursuing a career in the open source. All this fantastic collaboration between different people, all this dynamic and open world of exchanging ideas and knowledge. I'm really excited about building part of this open source Angular community, and thank you very much for being part of it as well. Thank you very much for your attention.